So this is an assignment related to chemical energetics and the bond enthalpy. We did the first 36 questions, so we'll start from 37. In this question, consider the following data. As you can see, a data is given A, B, C, and D are there, the different four reactions. What is the relation between A, B, C, and D? So to work out the relation, what you have to do, you have to relate these equations with each other and making a cycle, the Hess law, and then the overall energy change which happen or occur, it is independent of the route or the path which a chemical reaction take place. So if we see the first equation, in the first equation, we have sulfur plus hydrogen gives hydrogen sulfide. Then hydrogen react with oxygen give water. Then sulfur reacted with oxygen give um, sulfur dioxide, and hydrogen sulfide reacted with oxygen give. So if I try to relate them, these equations, like if I have sulfur, I'm not writing the state symbols. If I have sulfur and hydrogen, it will form hydrogen sulfide. And if a hydrogen is burned, so as a result, what will happen when like hydrogen react with oxygen, it will give water. So if this hydrogen is reacted with oxygen, like half O2, if we have half oxygen, what it will give, it will result in a formation of H2O. And sulfur will not change. Sulfur will be there because sulfur did not react. And then if a sulfur reacted with oxygen, if a sulfur reacted with oxygen, as a third equation is there, so what it will form? It will form sulfur dioxide and water is already there. Or hydrogen sulfide, if directly, as you can see this equation, hydrogen sulfide directly reacted with oxygen, what it will give? It will give sulfur dioxide and water. So now what we have, where the two arrows are pointing out, that is a start of the cycle. So where is the start of the cycle means this is a start of the cycle. And where the two arrows are pointing in, that is the end of the cycle. What are the enthalpy changes written here? If we see the first one, hydrogen reacted with sulfur give hydrogen sulfide, that is A. Hydrogen react with oxygen from water, that is B. Sulfur react with oxygen give sulfur dioxide, that is C. And hydrogen sulfide reacted with oxygen to give water and sulfur dioxide, that is D. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route. So if we follow route 1, according to that, A plus D is equals to, the root 2 is B and C. Like first it is B so that will be B plus C. So if we make A as a subject, so A is equals to B plus C minus D. So A is equals to B plus C minus D. With reference to that, A should be the right answer. Is it clear? So using the Hess law, we relate the reactions with each other. In which of the following does X represent the mean bond enthalpy? So what is the concept of a mean bond enthalpy? It is energy needed to break the bonds and produce atoms in a gaseous state. So substance in a gaseous state and we produce atoms in a gaseous state, what we call that as a mean bond enthalpy. So here the first one, why it is wrong? Because hydrogen molecule is produced. What about B? If you see, like we have water in a gaseous state and we produce one oxygen atom and we produce two hydrogen atoms in a gaseous state. So how many to break each bond we need X? Because the question is, in which of the following does X represent the mean bond enthalpy for OH? Like for each single bond between oxygen and hydrogen, the energy is X. Because here we'll break two bonds, so what is the overall enthalpy change? The overall enthalpy change will be equals to 2x. And we are producing atoms in a gaseous state. That's why B is the right answer. Why D is wrong? You can see here. Sorry, why C is wrong? Because in case of a C, hydrogen molecule is produced for a bond enthalpy. We should produce atom in a gaseous state. And if you have a water molecule here, why D is it not correct? Because what this enthalpy change is not X, it should be 2X. Because for one bond it is X, so we are breaking two bonds, then the total enthalpy change should be 2X. Equation is correct, but the enthalpy change is incorrect. Because for each bond the energy is X, so for two bonds the energy should be 2X. In question 39, consider the two equations given below. As you can see, hydrogen is reacting with water to oxygen to give water in a liquid state, and hydrogen is reacting with oxygen to give water in a gaseous state. And the enthalpy change for each reaction is, so we want to work out what is the enthalpy change when hydrogen gas is turned into hydrogen liquid. Look, when gas is turning into a liquid, it should be exothermic change, because like when gas turn into liquid, particles come closer to each other and it release the energy to the surrounding. So B and D cannot be an answer. B and D can be answered if a liquid was turning into a gas. But here a gas turned into a liquid, so means the reaction should be exothermic, so enthalpy change must be negative. Now, how to work out this? So again, we have to relate these two equations by using the Hess law. How we can relate? Example, we write the first equation. Hydrogen reacted with oxygen and it produced two water molecules and in a liquid state. Or hydrogen reacted with oxygen, it might produce two water molecules in a gaseous state. Or we want to find gas turned into liquid, so we want to find this energy when gas turned into liquid. This is unknown for us. When hydrogen and oxygen react and produce a water in a liquid state, the energy is minus 572. When hydrogen and oxygen react and produce water in a gaseous state, the energy is minus 484. So again, we apply the Hess law where the two arrows are pointing in, that is the end of the cycle, and where the two arrows are pointing out, that is the start of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route or the path we follow. So if we follow route 1, it will be minus 572. If we follow route 2, it will be minus 484 plus x. We need x, so this will go other side, minus 572 plus 484. So this will give us the value for x. So because it should be an exothermic, why it should be an exothermic? Because as you can see, the gas is, so that's equals to minus 88 kilojoule per mole. So C should be the right answer. Is it clear? This one? Okay. So it's important that you relate the two equations by making a cycle. In question 40, which equation represent the reaction for which the enthalpy change is the mean bond enthalpy for CF, like average bond enthalpy? They say about the mean bond enthalpy, means they're asking to break energy needed to break one bond, like, or the average of the total. So in which one enthalpy change is representing here in a CF, carbon bonded with 4 fluorine. So this enthalpy change will be equals to 4x. Why 4x? Because we are breaking 4 bonds. Here, like, we are breaking 4 bonds, but then we took a quarter, like 1 by 4. So it will be delta H is equals to 4x divided by 4. Like, we took a quarter of this. Total 4 bonds are broken and we took quarter. So what will be the enthalpy change? It will be X. That's why B is the right answer. C and D are totally wrong because we are not breaking the bond here. It's a bond forming. Then, in an experiment to determine the enthalpy change of a combustion of alcohol, a spirit burner containing an alcohol was weighed, lit, and placed under a copper can. So, how we work out the enthalpy change of a combustion? We have a spirit burner, which is filled, example, with alcohol. When we burn, it produces heat energy, and that causes a water temperature to rise. The temperature rise of a water was measured, and the burner reweighed. The enthalpy change calculated from the results was much less exothermic than the value we report in the literature. Which of the following factors is most likely to be a cause of this error? Like, why we have a smaller enthalpy change as compared to a predicted value? So heat loss around the side of a copper, that's true, because it's not like all of the heat is transferred to the cup, some of the heat lost to the surrounding. So maybe combustion of this, maybe burning of this might produce, say, 100 joules, but not all 100 joules will give out the same amount. So heat loss to a surrounding is a likely reason that we'll have a smaller enthalpy change than the value quoted in the literature. Use of a thermometer or a measuring cylinder or evaporation of alcohol during a weighing, that factor is not the most likely. The most likely is the heat loss to the surrounding, as not all of the heat is transferred to the water in a copper cup. As a result, the enthalpy change will be lower because we have the formula E is equals to Cm delta T. So idea is that because what we did, we measured the mass of a spirit burner and alcohol before and after. So if we have a greater mass, like greater difference in the mass, will get a greater enthalpy. So evaporation of alcohol during a weighing, so that will increase the rate of what it will do. It will increase the change in the mass. As a result, if we have a greater change in mass, the enthalpy change should be higher. But we are getting a smaller enthalpy change. Specific heat is constant. So what other factor can affect? That's the temperature. So as a heat loss to the surrounding, the temperature change will be smaller. As a result, the enthalpy change will be lower. Is it clear? Question 41. Okay. In this question, the standard enthalpy changes of formation of a carbon dioxide and methanoic acids are given. Calculate the enthalpy change of this reaction. So whenever a formation is given, what we add a link, we add a link of element. Whenever in a question, if a formation is given, what you will do, you will add elements. What are the elements? We have carbon, we have oxygen, and we have hydrogen. Element will form the reactant, then reactant form the product is same as element directly form the product. This is unknown for us. The formation of a car in the question, this is formation of a carbon dioxide. Hydrogen is not formed here because before and after it is same. So minus 394 is enthalpy change for minus 394 is enthalpy change of formation of a carbon dioxide, and minus 409 is enthalpy change of methanoic acid. When we apply the Hess law, the overall energy change is independent of the route or the path we follow. Where the two arrows are pointing out, that is the start of our cycle, and where the two arrows are pointing in, that is the end of the cycle. So if we follow route 1 or we follow route 2, overall energy change is independent. So it will be minus 394 plus enthalpy change delta H is equals to minus 409. So if we need delta H, that is equals to minus 409 plus 394. So this will give us minus 15, the enthalpy change. So with reference to that, B should be the right answer. And there's also a direct method whenever you have the enthalpy changes, like a formation is given. So how to work out the enthalpy change? It is a product minus the reactant. So this is a product, this is a reactant. So product minus reactant, you will also get the product is like minus 409 minus and then minus 394. You will get the same answer, minus 15. So you can, but remember one thing, that whenever formation is given, it is product minus reactant. But if it was a combustion is given, combustion was given, then it will be reactant minus the product, opposite. Which of the following change is a value of delta H negative? Means like which is exothermic, because delta H negative refers to an exothermic reaction. So which is exothermic? If I want to remove electron from potassium, because what will happen, energy is needed to remove electron, so we have to provide some energy. Even natural tendency of a potassium is to lose electron, like metals have a tendency to lose, but still we have to provide, or they have to gain some energy to transfer their electron. So A is actually an endothermic change. So remember, whenever ionization energies are always endothermic. When potassium ion and chloride ion, like in a lattice, we break down and produce, like we separate them. So if we want to separate the ions from each other, we have to provide energy so they can move away from each other. So potassium and chloride ions, we have to supply energy that it turn into potassium and chloride ion gases. So this is also endothermic because we have to, it is opposite of lattice energy. Lattice is when ions in the gaseous state forms a compound, that is called a lattice energy. But in this case, it's opposite of lattice. Lattice as an energy is exothermic, so this will be endothermic. And it's a bond breaking, like you break the attraction. That's why it is also endothermic. Then chlorine atom, we have it gain electron and turn into chloride ion. So whenever affinity, first electron affinity is always exothermic. Electron affinity, because it's like a bond forming. Bond forming is exothermic. There's a bond formed between the chlorine atom and the electron. The second electron affinity will be endothermic because we have to provide energy to overcome the repulsion of the negative ion. And here we are breaking the bond. Bond breaking is endothermic because we are breaking a bond in producing two chlorine atoms. So with reference to that, C should be the right answer. In question 44, the enthalpy change for the reaction between hydrochloric acid and sodium hydroxide is minus 56. So if it is minus, it's an exothermic. What will happen in exothermic reactions? Exothermic reaction, as it releases the energy. So what happened to the temperature? The temperature will rise. So A will be the right answer, because the reaction occur, it give energy, so the temperature of a mixture or a solution will increase, because particles, like say this is representing a particle of hydrochloric acid and this is sodium hydroxide. When these particles combine from sodium chloride and water, that releases energy, and that energy is absorbed by the solution, or which is a part of surrounding, and its temperature will rise. So exothermic reaction temperature increase, endothermic reaction temperature decreases. The standard enthalpy changes of formation of some sulfur species are: sulfur 8 is given, formation is 0, sulfur in a gaseous state is 103, and sulfur atom is 279. Enthalpy change of atomization. What is the meaning of atomization? Like we have a sulfur solid and we produce atoms of a solid. Like the concept of we have sulfur solid is there and we produce sulfur gaseous atom. But sulfur as it is existing as S8 and we want to produce one sulfur atom in a gaseous state, this is what we need. So this should be 1 by 8 because 8 sulfur atoms will 8 sulfur atoms in a molecule will produce 8 sulfur atoms. So we want to produce only one, so this should be 1 by 8. Now how to work out? So we want to produce one sulfur atom in a gaseous state. Now in the question, when sulfur solid is there, formation is because it's already there, so formation is 0. But formation of a sulfur 8 S8 is in a gaseous state is 103, and formation of a sulfur in a gaseous state is 279. What does it means? Like when we produce one, so this you don't need a calculation because it's already given. When sulfur atom is produced in a gaseous state, the energy is 279. Like if I want to produce a one sulfur atom in a gaseous state, the enthalpy change, the energy change is 279. And how this one sulfur atom will be produced? We need 1 by 8 of S8 in a solid state. But we don't bother about what is there in the reactant side because for atomization, we see how many atoms are produced. So it's already given in the question that to produce one sulfur atom in a gaseous state, you need 279. So that's why C is the answer for this. So even the answer is given in the question because atomization means energy needed to produce atoms in a gaseous state. And it's already given to produce a sulfur atom in a gaseous state, it is 279. That's why C is the right answer. Is it clear? Question 45. In question 46, for which of the following reaction is the enthalpy change equal to a bond enthalpy? Bond enthalpy means energy needed to break the bond or mean bond enthalpy. So, and produce atom in a gaseous state. Here we are producing molecules, so this cannot be. Here we are producing ions, so this cannot be because that is opposite of lattice. So here we are producing atoms in a gaseous state. So when we break the bonds and we produce atoms in a gaseous state, what we call that energy, we call that as bond enthalpy. Question 47, the equation for a complete combustion of pentane is there. The standard enthalpy changes of formation are given. So when formation is there, it will be product minus a reactant. Like you can do it directly. So if the energy change is equals to the product minus the reactant. This is direct method. So standard enthalpy change of formation of a pentane. This is one, or you can also work out by using a Hess law. So standard enthalpy change of formation of a carbon dioxide, like we have this equation C5H12 plus 8 oxygens will give 5 CO2 plus 6 H2O. So when formation is given, what we do, we add another link, and that link is element. What are the elements? We need 5 carbon atoms, we need 6 hydrogen molecules, and we need 8 oxygen. They will react and form the reactant, or they will directly form the product. So 5 carbon, 6 water, and 8 oxygen. What it will produce? It will produce C5H12 plus 8O2. Or 5 carbon, 6 hydrogen, and it will produce carbon dioxide and water. We want to and the enthalpy change of a combustion when we burn, this value is given. This is minus 3509. That is given to us. The formation, this is a formation of a C5H12, like this is a formation of a pentane. So this is unknown. We say this is X. And what about the formation of a carbon dioxide? The formation of a carbon dioxide is 394. So minus 394 times 5. Why multiplied by 5? Because 5 carbon dioxide molecules are produced. And this is also a formation of a water molecule. How many? The each molecule is minus 286 times 6. So when we follow the route, the reactant, like the element form reactant and reactant forms the product, is same as element directly form the product. So this will be X. If we write because where 2 arrows are pointing out, that is the start of the cycle, and the 2 arrows are pointing in, that is end of the cycle. So this will be X minus 3509 is equals to 5 times 394 plus 6 times minus 286. And this will go other side. So this will become positive. So this X will be equals to, because we need X, so it will be 5 into minus 394 plus 6 into minus 286. And this will be minus, this was minus here, so this will become plus. Or because we need a positive sign here, so it will be 3, no, because we completely change the sign, so it will be 3509. So we check which option it matches with, because this will be minus minus plus, this also minus minus plus. So 5 into 394 and 6 into 286. But 3509 should be positive sign. So 3509 should be here, it will become negative sign 3509. Here, why this is wrong? Because it should be added, not subtracted. So this is wrong. Here also it will become a positive minus minus. So but with reference, like these signs are wrong. So when we simplify, this will give us B as a right answer. Is it clear? Question 47. The enthalpy change of a formation of pentane. Okay. Then we have a structure questions from enthalpy changes, chemical energetics, and bond enthalpy. The table shows some of ionization energies are there. Complete the table by predicting the third value. So the ionization energy of magnesium. Look, magnesium belongs to group 2. So the first 2 ionization energies should be comparable, because it is removed from the last shell is having 2 electrons. But this should have a greater difference. Like the third ionization energy should be closer to the fourth one. And between the fourth and the fifth, the difference is about 3000. So this will be about 3000 or 2000, like you write 8000, that is correct. Why there should be a big difference? Because magnesium belongs to group 2. So group 2 elements have 2 electrons in the outermost shell. So first 2 ionization energies should be comparable, and the third should have a greater difference. Then write equation for the third ionization. So magnesium already lost 2 electrons in a gaseous state, and we remove the third electron. We call that as a third ionization energy. A version of a Born-Haber cycle of a magnesium chloride is shown. So how you can identify which is the start of the cycle where the two arrows are pointing out. So at this point, the two arrows are pointing out, that is the start of the cycle. And at this point, the two arrows are pointing in, that is the end of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route or the path we follow. Identify the enthalpy changes from a Born-Haber cycle. Delta H1 is the sum of the two enthalpy change, and you should give both. So what is delta H1, delta H2, and delta H5? What is delta H1? Look, in delta H1, we convert the magnesium atom into magnesium gas. So means this is atomization of a magnesium. And here we convert a chlorine molecule to two chlorine atoms. So this is twice the atomization of chlorine. Why twice? Because two atoms are produced. And this is atomization of magnesium. So delta H1 is actually a sum of atomization of a magnesium plus twice the atomization of a chlorine. What about delta H2? In delta H2, chlorine does not change, but magnesium has turned into iron. So this is, what is delta H2? Delta H2 is actually the sum of first and the second ionization of magnesium. It's not like only first, because two electrons are removed. So it is the enthalpy change for the second one is actually a sum of ionization, the first and the second ionization of energy of magnesium. What about delta H3? So this will be ionization of magnesium, first ionization plus the second ionization of magnesium. Like when we produce magnesium ion in a gaseous state, so this will be. What about delta H3? In delta H3, we have chlorine. The only change what happened is the chlorine molecule turned into chloride ion. So this is gaining electrons, so it is affinity, because when electron it gain electron, it's affinity. So this enthalpy change is affinity of a chlorine. But it should be twice. Why twice? Because we are producing two chloride ions. If it was only one chloride ion, we will write one, but two chloride ions, so it will be twice. And then what is delta H4? When magnesium ion and two chloride ion form magnesium chloride, so that enthalpy is the lattice energy. And what is delta H5? When elements magnesium and chlorine form magnesium chloride, so this is a formation of magnesium chloride. Because when elements form a compound, we call formation. So when we convert in produce atom in a gaseous state, atomization. When we remove electron, ionization. When electrons added, affinity. When ions combine and form a compound, lattice. When element form a compound, that is formation. So here we have to fill delta H1, delta H3, and delta H5. Use the data, calculate the delta H2. How we can write equation for delta H2? Because if we follow the Born-Haber cycle, or using a Hess law 1, 2, 3, 4. So it means delta H1 plus delta H2 plus delta H3 plus delta H4 is equals to delta H5. So if we need delta H2, all the rest will go other side. So delta H5 will be equals to delta H2, not 5. Delta H2 is equals to delta H5 minus all of them move other side, means delta H1 plus delta H2, delta H3 plus delta H4. So we add them and subtract from delta H5. That will be the equation to get delta H2. So here we have to write equation for delta H2. So that's how it can be done. Then the values of delta H1, 3 and 5 are given. You just have to substitute these values and get the answer. Like the question is, use your answer, calculate the lattice energy. Delta H4 we have to calculate. So if you want to calculate delta H4, we will just use the same formula, delta H1, delta H3, delta H2. We need this, the lattice energy. So use the data, calculate the value of delta H2. How we can calculate the value of delta H2? As you can see, what is delta H2? Delta H2 is uh, magnesium is producing two ions, like magnesium plus two ion is produced. This is so. What will happen? Like first ionization is this. The second ionization is this. So to get the delta H2, what we simply do, we will add them. So you just have to add the first and the second ionization, you'll get delta H2. And then delta H4, you can make the equation, the Hess law, and work out the delta H4 from that. Then a similar Born-Haber cycle can be drawn for calcium chloride. In calcium chloride, the delta H2 is less positive. Explain why. Delta H2 compared to this magnesium, it is less positive. So what is the reason for that? Like less endothermic, because if you see for magnesium, when we are removing electron, first shell 2, second shell 8, third shell 2. But in case of a calcium, first shell 2, second shell 8, third shell 8, and the fourth shell 2. If I want to remove the electron from calcium, it is much more easier as the electrons are far from the shell, weaker attraction. So I need only, like example, 90 joules, kilojoules example. But here, if I want to remove, a stronger attraction is there. So I might need 200 joules. So answer for this, because calcium is having more electron shells, electrons is further from the nucleus, so weaker attraction. As a result, smaller amount of energy can remove the electron. That's why it is less endothermic or less positive. Explain why the value of a lattice energy is less negative for calcium chloride. Look, lattice energy depends on the size of the ions. Size of the ion should be smaller to have a high lattice energy, and the charge on the ion should be greater to have a higher lattice energy. These are the two factors which affect the lattice energy. So in case of a magnesium chloride, magnesium ions are smaller compared to calcium ions. Chloride ion is same, but magnesium is smaller, chloride is larger. So magnesium chloride, as the magnesium ions are smaller in size, so they will have a stronger attraction. How you'll score the marks, or you can also mention charge density. So magnesium has a higher charge density, or magnesium has a greater charge density, you can also say, or magnesium is smaller in size. So it will have a greater attraction towards the chloride ion. So stronger attraction means more energy required to separate the ions from each other. So the lattice energy depends on the size of the ions and the charge of the ions. Size of the ions should be small as possible, and the charge on the ion should be large as possible. So this was question 48 from the chemical energetics and the bond enthalpy.